Hello, my chemistry students. We're now on to the second half of Unit 1, so let's dive right into it. Today, for the second half here, we're going to be talking about learning targets number 1 and number 2. Okay, so first thing we talk about is quantitative and qualitative. Qualitative is a quality that doesn't have a number attached to it, like the sulfur is yellow. The yellow color, that's not a number, so it's qualitative. Quantitative means there's a quantity which says that there's a number attached to that. So if I say my hair is 1 meter long, I have a number attached to that. So it's quantitative. You also have intensive and extensive. So intensive properties, it doesn't matter the size of the sample, the property stays the same. Extensive means if you change the size of the sample, it also changes that property. So again, if we go back to our sulfur, if I cut my sulfur in half, it's still yellow, so that's an intensive property. Extensive, the mass of the sulfur is 100 grams, but then I cut it in half, now it's 50 grams. So that quality changed, that value changed, so it's extensive. Okay, so with this in mind, go through and say, okay, mass, it's quantitative because there's a number attached, and it's extensive because when I change the amount, the mass changes. Okay, go through each of those and tell me what you think. Actually, I'm going to grab my other set of notes that I have filled out. Sorry, 1 second. Okay. So now we're going to start talking about SI units and what an SI unit is. First thing, this is a standard international, so it's the standard across essentially the world. Because if we can get in science where we're using the same units, that means that we can then use the same equations. Okay, so for mass, we like to keep things in kilograms or a prefix of grams. Length, we can keep in meters. Volume is in liters. Temperature is in Kelvin, and time is in seconds. Okay, memorize those. You will need to know what value connects to which SI unit. Okay, the other thing that the slides talked about was common prefixes. Okay, so here, kilo means 1,000. So if I have 1 kilogram or kilogram, then I have 1,000 grams. Okay, milli means 1/1000th. So if I have 1 milligram, I have 0.001 grams. Okay, centi is 1/100th. So if I have 1 centimeter, then I have 0.01 meters. Now you could look at this the opposite direction as well. You could say if I have 1 meter, that means I have 100 centimeters, and if I have 1 gram, that means I have 1,000 grams. And if I have 1 gram, I would only have 0.001 001 kilograms. Now a derived unit is when we take these variables with SI units, and we mathematically manipulate them, which means that we then manipulate the units as well. So like mass divided by volume is density, how much mass we have within a given area. And so the units are grams per milliliter usually, and that is a derived unit for density. Okay. Area is a derived unit because it's length times by length, which is meter times by meter, so we mathematically manipulated that. Okay. The other important thing to know is the correlation between 1 cubic centimeter and 1 milliliter. Okay, so listen closely, add it to your notes if you need to. 1 cubic centimeter is the same as 1 milliliter. So if I have 1,000 cubic centimeters, that means I have 1,000 milliliters. Now 1,000 milliliters is 1 liter. So 1 liter is the same as 1,000 cubic centimeters. Okay, temperature. For temperature, we use the unit of Kelvin. Now, when we have 0 degrees Kelvin, that is negative 273.15 degrees Celsius. Okay? So 0 degrees Kelvin is very, very cold. Now, the way that we convert from degrees Celsius to Kelvin is we add 273.15. Okay? And then that will get you to Kelvin. That's the most common conversion that you're going to see there. Okay? When you're measuring length, we measure in meters or, a prefix of that like centimeters or millimeters. And so it's really important that you memorize these conversion factors, that you know that there are 100 centimeters in 1 meter. Or, this is the same thing looking at it in another direction. 1 centimeter is the same as 1/100th or 0.01 meters. So that conversion factor is very important to remember. Same thing here, okay? And then the cubic centimeters and the milliliters. Know that as well. All right. We're measuring our length here, centimeters and millimeters. Okay, so how long is the red line in centimeters? So it's 2.70 centimeters. And how long is the red line in millimeters? Where there's 10 millimeters in every single centimeter. So we have our 2.7, and we'll times that by 10, and that's how many millimeters we have. Now, here's what's really important. It's very important that you memorize these conversion factors, that you know kilo of something, like 1 kilogram, is the same as 1,000 grams, or 1 kilometer is the same as 1,000 meters. The other item that's important to remember is that centi is essentially 1/100th. So if I have 100 centimeters, that's the same as 1 meter. Milli is also important. Those are the 3 that you have to have memorized. If you have 1,000 millimeters, that is the same as having 1 meter. So you're for sure going to run into items just like this. You have to know if I have 1 meter, that's the same as 100 centimeters. And here's 105 centimeters, so that one's the larger one. Or if I have 1 meter, which is 1,000 meters, and I have 1,200, so I have 1 meter, which is 1,000 millimeters, and I have 1,200 millimeters, that one's larger. Okay, mass. Measured in kilograms, but often grams as well. So be careful with those prefixes again. 1,000 grams is the same thing as 1 kilogram. Maybe you should make flashcards. That might be helpful to remember all these conversion factors that you saw in your notes when you were going through the slides. Okay? And so when we look at this ratio here, sorry, I'm trying to get the glare. When we look at that ratio, we see that 1,000 grams is the same as 1 kilogram, or 1 gram is 1/1000th of a kilogram. Sorry, they're cleaning the hall right now. Waxing the hall. Okay. I think we are good and we've talked through this. Here is those conversion factors. So these are the items that I would get down and I would have these memorized. Here's where I was talking to you about how a cubic centimeter, oh, that one's incorrect, right? 1 cubic centimeter is equal to 1 milliliter, so 1,000 cubic centimeters is 1 liter. And so was the ratio of cubic centimeters to liters, it'd be 1,000 to 1. And then the ratio of liters to cubic centimeters again. We have 1,000 cubic centimeters in 1 liter. So if we have 1 cubic centimeter, then that's the same as having 0.001 liters. You're going to want to take a minute and to look through this. Okay, 12 milliliters is the same as 12 cubic centimeters. Those are identical, just like 1 milliliter is the same as 1 cubic centimeter. It's really important that when you make these measurements, you're looking at these calibration marks at eye level. Okay, so don't look up above at an angle or below at an angle. Look directly at eye level. And when you're measuring liquids, you should be reading from the bottom of the meniscus. Okay, so when I look here at this example, I have 40, and then 1, 2, 3, and that's the bottom of my meniscus. Even though the higher end is up above, maybe even at 4, the bottom of the meniscus is at 43. Hopefully you're familiar already with measuring volume. Volume is width times by, well, let's see what, base, width, and height, right? It's that 3D shape. So it's going to be 10 times by 8 times by 9. And your units are also multiplied. So you don't have units of centimeters, you have units of cubic centimeters. Now we can also figure out volume through displacement of water. So originally we had a certain amount of water in there. So it was at 200 cubic centimeters. And now we see that when the object was dropped, we're at 265 cubic centimeters. So the difference between them has to be the volume of the object. All right. So that's what we talked about in class. Let me know if you have any questions. You can always email me. Okay.